Okay. Have you ever really thought about what it takes to teach a robot something new? I think most of us, we picture complex code, maybe engineers huddled around computers, that whole scene. But what if that picture is, well, changing fast? Today we're doing a deep dive into something pretty exciting coming out of MIT. It's work from their engineers that's making robot training way simpler, like potentially letting almost anyone teach a robot.
So, our mission here is to figure out how we're moving from needing intense programming skills to something much more intuitive.
Yeah, and it's not just a small tweak, What these MIT researchers have developed is called a Versatile Demonstration Interface, VDI for short. And the really clever part, I think, is how it bundles different training methods all into one handheld tool. It kind of sets the scene for understanding not just what it is, but why it's actually a pretty big deal for how we might work with robots down the line. That is fascinating.
Yeah.
Because, the old way, that barrier was always the coding, right?
Yeah.
You needed serious expertise just for basic tasks. But now there's this shift towards robots that learn from demonstration, LFD. It sounds like a totally different way of thinking about it.
It really is. Learning from demonstration, or LFD, it's this emerging strategy in robot learning. The whole push is to make training robots feel more natural, more human, you could say. Mike Hagan now, he's a postdoc at MIT involved in this. He put it nicely. The goal is creating highly intelligent and skilled teammates that can effectively work with humans to get complex work done. So it's more about collaboration than just, pure automation.
Okay, so if we want these smart teammates, robots that can adapt, how do we teach them without needing a computer science degree? And that's where this VDI comes in, right? This Versatile Demonstration Interface. Can you describe it a bit? You said it's handheld, packed with sensors, and it attaches to existing robot arms. That sounds key.
It is key, yeah. The compatibility is huge. So physically, it's this handheld device. And technically, it's quite smart. It's got a camera, special markers. These let it track exactly where the tool is and how it's moving in 3D space. Plus, it has force sensors, so it measures pressure, how hard you're pushing or pulling. All this data gets captured, and that's what the robot uses to learn the task.
Okay, and here's where I think it gets really interesting. You mentioned it combines multiple training methods, not just one, but 3 different LFD approaches, because usually robots are kind of specialized in just one way of learning, isn't that right?
That's generally been the case, yeah. This integration is what makes the VDI so versatile.
So it's like giving the robot a whole teaching toolbox. Let's unpack those 3 methods.
Okay, first up is teleoperation. This is basically remote control. Think operating it from a distance, maybe with like a joystick or similar controls.
Right, which makes total sense for dangerous stuff, yeah. Like the example in the research about handling toxic materials, you wouldn't want to be right there.
Exactly. Safety first. Allows precision from afar. Okay, then the second method, kinesthetic training.
Kinesthetic. So, hands-on.
Very hands-on. This is where you physically grab the robot's arm and guide it through the motions you want it to learn.
Oh, okay. Like literally showing it the path. I can see that being super useful on, say, an assembly line. You can show it how to box something up or maybe help a worker adjust how a robot lifts heavy items. That direct feel must be helpful.
It's very intuitive for a lot of people who work with their hands, yeah. And then there's the third method, which they call natural teaching or just demonstration. For this one, the VDI tool is actually detached from the robot arm. The person just performs the task themselves, holding the VDI, and the robot watches and learns by observing.
Wait, so the robot is literally just watching me or you do the task with a tool in hand?
Yeah, the tool captures your movements, the forces you use, while the robot's camera watches.
Wow, that opens up a lot, like drawing a logo example.
Exactly. Or intricate tasks that need really delicate, precise movements. The robot learns by seeing a human expert do it naturally.
That really does blur the lines, doesn't it?
It does. It learns from that visual example combined with the tool's sensor data. But the real power here is the flexibility. Users aren't stuck with just one method. They can pick and choose, mix and match, whatever feels right for them or the specific job.
Okay, so theory is one thing, but they tested this out in the real world too, right? Took the VDI, hooked it up to a standard collaborative robot arm, and went to a local innovation center, got actual manufacturing experts involved.
They did. They wanted feedback from people who actually do these kinds of tasks day in, day out. They had these volunteers train the robot on 2 pretty standard manufacturing jobs. One was press fitting, basically teaching the robot to push pegs into holes accurately, a common assembly thing. The other was molding, getting the robot to push and roll this sort of dough-like material evenly around a rod.
And they had the experts try all 3 training methods for both tasks?
Teleoperation, kinesthetic and natural teaching for both the pegs and the molding.
And what was the verdict? Did people prefer one style?
Well, the overall finding was pretty clear. Most volunteers preferred the natural teaching method, the one where they just demonstrate the task.
Yeah, interesting. But I guess preference isn't everything.
Not entirely, and this is important. The experts themselves pointed out situations where the other methods, teleoperation or kinesthetic, would actually be better, depending on the specifics of the task or the environment. So their feedback really highlighted why having all three options in one tool, that versatility, is so valuable. It's not one size fits all.
Okay. So zooming out then, what's the bigger impact here? It's more than just training flexibility, isn't it? It feels like it could really change who gets to teach robots. Democratize it, maybe.
Yeah.
And potentially let robots learn a much wider range of things. I think democratization is a good word for it, yeah. It broadens the pool of potential robot teachers significantly. And the vision definitely goes beyond just factories. You could see this leading to more robots in places like homes or maybe in caregiving settings eventually. And even on the factory floor, think about it. A worker sees a robot doing something slightly off. With this, they could potentially, quickly and naturally adjust the robot's movements right there, in the moment. Instead of having to stop everything, call a programmer, wait for software updates, it's much more dynamic. Mike Hagenau is actually presenting a paper on all this at the big IROS Robotics Conference this fall. That's a huge practical difference. Less downtime, more direct control for the people doing the work. So really, the takeaway seems to be that this tech lowers that huge barrier. It moves robot training away from the specialists, the coders, and makes it much more about just direct human skill and instruction.
Absolutely. And it kind of underscores a broader point, I think. Knowledge is great, but it's the application, the understanding of how to use it that really matters, especially now with so much information out there. Being able to see how an innovation like this VDI actually changes things, that's a crucial skill. Critical thinking about the implications.
Yeah. It makes you think, doesn't it? So here's something to chew on as you go about your day. If you could teach a robot a new skill just by showing it, what would it be? Think about tasks that are maybe creative or really personalized. What kind of unexpected things could robots learn? What collaborations could happen when teaching them becomes this intuitive, this accessible? What doors does that open?